Hello YouTubers, hello. This is the start of experimentation time. I've never done very much experimenting due to lack of time, but I've got a lot of time, so I want to make a use of it by doing some experiments. So while we're looking at a magazine, Everyday Electronics, this issue was March 1972 and it cost 15p, and I bought this on the internet on eBay. And this magazine holds a very special part of my life because there's a project in here that I did all those years ago which I found extremely very useful. Now, when this magazine, or the year of this magazine, I was 9 years old. It kind of put together some kind of scale of time. It wasn't 30 years ago, it was more like 45 years ago that I did electronics. And I was only very, very young. I think I did electronics up to when I was about, I don't know, 15, 16, 15, something like that. That's a guess mine. I have no idea, I can't remember. But the project we're looking at is the signal injector. Basically, it's a square wave generator made into a pen. So I've had a bit of a play around. Now, the problem with this injector is it's designed with two transistors that was hard to get hold of back then, and it's even more impossible to get hold of now. The transistors that this uses is OC44s, and for some reason I got stuck in my head that it was OC72s, I think it was, or one of those other old transistors. These transistors are very, very early transistors that come in a glass case. Very, very early transistors, and they are very, very, very obsolete back then in 1972. So 2017, they're kind of a bit hard to get hold of. Now I've got a massive big bag of germanium transistors. I don't mean that bag, I mean a big shopping bag full of germanium transistors, which I bought from Bulgaria and Russia. And I thought maybe there might be a chance that I might be able to play around with these and make that circuit. Now the transistors aren't in here because I've been playing around, but the circuit isn't working because probably it's set up for the other transistors and not for these, or the other ones that I experimented with. So it looks like we're going to end up using maths and calculations, which is something a lot of us avoid, and I certainly do avoid in playing around with this simple circuit. So for me, being a simple circuit is a good place to start, as I've never done any calculations to work out what will or what will not work. So we have a look at the schematic and the details of this, and I'll show you what I mean. This is what I was on about. It's absolutely useful project to do, very handy. Only I never bothered with the cylinder pen thing, as I didn't know where to get hold of, or how to get hold of anything like that back then in those days. When I actually made a project, I don't know what age I was, but that was the age when this magazine came out. That's the simple circuit diagram. It's a very simple diagram. As you can see, the positive and the negative, which way around the circuit works, because these transistors are PNP transistors and they are OC44s, but for some reason I got stuck in my head OC77s or 71s, I can't quite remember, one of those. And this is the waveform that it generates, and this is the layout of the circuit board. And I actually made this all those years ago. No, obviously, I don't know exactly when I made it, but, you know, give you some idea. That's the layout. I had a battery soldered onto a piece of circuit board. I had it glued on. I had, for probes, 2 wires. I still have the same wire around somewhere. Blue solid wire which kept breaking off. It was a big, I used a big massive capacitor, 1000 volt, one of those big white doubler capacitors. But of course, if you inject into a voltage which is a signal, it can go back up into the transistors, which I think probably what happened to the original one that I made. There should have been a diode put in to stop anything coming back up, and there was no diode in this. So we've got a simple schematic of the basic layout. So what I'm going to try and do is try and make it either with the germanium transistors I have here, which I have in abundance, or try and make this circuit with ordinary silicon type transistors. But we can play around to our heart's content, can't we? So for the next few days I'll be experimenting with this. Now I have scanned all the pages of this magazine into my computer so that I will not lose this magazine again. But I will not be using these transistors that's in this, OC44s or OC71s. Have you seen how much they want for them? One on eBay was £6 something, which I think's too dear. And there was another one on there that wanted over 15, nearly £16 for one transistor. You got to be kidding. I think they were about 17 pence years ago. How much I paid for the ones that I got and where I got them from, I just don't know. I was hoping maybe one day that I'd come across some old electronics that had these transistors in. But waiting for that is probably waiting for the end of the world, because it's not going to happen, I don't think. So, as we've scanned this magazine into our computer, we don't need to use that anymore, because at the end of the day, keep turning the pages over will just make the magazine deteriorate, because the pages are very brown and very brittle. So I've got the schematic and the details here, which is this. So what I plan to do, I'm not going to film every single experiment and every single failure. I'll just play around, and as I get progress, I'll film my progress, if I get anywhere. If I don't get anywhere, then we'll just take it from there. So I just thought I'd share that with you. 9 years old when this magazine came out. I couldn't believe it. And I made this exact same project all those years ago. And I'd already damaged it, blown transistors up, whatever, before I had went for my first job in Purley, a place called Forbes Rentals. Might not be trading now. I'm certainly not going to go and find out. They're a long way away from where I live now. So, how this circuit works, basically, how it's set up, is it's like a flip-flop, and you've got 2 transistors which are wired in such a way that they turn each other off. So one transistor turns on, in turn turns the other transistor off, which then and it's like a flip-flop. So the square wave is generated by one transistor turning off and turning the other one in the opposite way, and vice versa. And it's a continuous thing, giving you a square wave, a pure square wave. But, as I say, these Russian or Bulgarian transistors are nowhere near the right transistors for this, their working voltages are very different. So I'll experiment and see how far we get. We can see our progress on the Fluke oscilloscope. Okay, so I'll see you whenever that is. Now this segment was filmed at that time, at that date. It's now the 27th of the 8th. I'm doing this on purpose to make sure you got the time and date, so you know how long it is taking between each experiment when I've filmed it. And I will be doing other things in between, so this video might be filmed over many days. Okay, so I'll see you later. Right, I just want to update you on where we're up to so far. I have tried, I think, 4 different transistors, and I've not been getting any results until now, until I put the most unlikeliest transistors in this circuit, and I've actually got a result. That's what I'm getting on my scope. Not exactly what I'm looking for, but it's a result. I'm getting somewhere. And at the moment that's running on quite a high voltage. I've turned the voltage up, so let's turn the voltage down. Says me turning the voltage down now. That's, according to the meter on the power supply, that's 5 volts. I'm looking for something that will run on about 1.5 volts. And that's the waveform we're getting. So a bit more playing around, but I've got a result. I've actually got an oscillator working using those transistors. So you're going to be asking me, what transistors are those? Well, this is what I wrote on the paper. It's a GT404A, which is equivalent to an AC176. It's 25 volt NPN, collector power 0.6, collector base, collector emitter max. I don't understand my writing here for a moment. Forward current is at 21 milliamps. MH I've got, I don't understand what I've written there. But anyway, it was supposed to be able to run on 25 volts. And we're running it on 1.5 volts at the moment. And it is oscillating quite happily. No electrolytics in sight. All it is in the circuit itself is 2 capacitors, 4 resistors, 2 transistors. This is just to isolate from outside, so you can inject this into a radio or something. But the plan is I want to be able to make a small injector device that will run on 1.5 volts and inject a signal into a radio. A bit like what I had before, and I don't want to be spending stupid money buying old OC Mullard transistors when we've got a massive amount of transistors. Now the problem with having all these Russian and Bulgarian transistors is that I'm not 100% sure what sort of circuits they're all good for. So a lot of it's trial and error. So I just kept trying them. But the problem you've got to remember is that some of these transistors it's base middle, some of them it's base on one end, and it changes. So yeah, a success. Right, I'm going to go and check on the computer now and see if we've uploaded our video, the one that you've all been waiting for. See you in a bit. Hello YouTubers. This is it's nearly 12 o'clock and it's the 29th of the 8th. I said I was trying to save up money to recoup from what I bought. Oopsie daisies. Recoup from what I bought, the 2 signal generators. And we were doing quite well until this weekend. This weekend I have bought a lot of parts, bulk parts. There's parts that I don't need that I've already got thousands of, but you have to take potluck with all this kind of stuff, and it just seemed too good to miss. Very, very cheap, thousands of parts. Two lots in one auction and another lot in a different auction, and when they're going for those kind of prices, you know, you have to take the opportunity. And also I bought these. There's 100 capacitors, mixed capacitors in each of these bags, and they're sold off cheap because they're cosmetically failed. Nothing wrong with the actual caps themselves, but if I zoom in a bit there, you can see one there in the middle of the picture that hasn't been dipped in the insulation material. So it's take potluck. Now these capacitors, they're Phillips type, and they're the next generation up from the tropical fish capacitors that we used to get back in the 70s and the 80s. So now these caps, there's many different values here. They're all mixed up, but they're ideal for working on breadboard. The only snag with them is the values in that are in writing across the top of the capacitor, and it kind of makes it a bit tricky to see them when you're an old fart like me who can't see. So I don't know whether I'm going to sort them out or not. The voltages range from anywhere between 100 and 400 volts, the advert said. I probably wouldn't be using them on those kind of things, mostly because the leads would probably be too short anyway. So I come back to the bench and thought we'd have a bit more experimentation. Right, that's the time. Seem to work better at certain times than other times, and the date's the 29th or the 8th. And I've been working through this book. Now I've got permission to mention this book from the author, as you all know him as Radio Fun 232, and this is his book, Schematics 1 Revised. K.O. Tillman is his name. Now ohms has always been the mathematical side of the maths behind ohms has always eluded me. I've never really spent much time even to look at it. So what I've been doing is I've used the calculator on my phone, which works out everything for you automatically, and I've also used the calculator. And those of you who already know this will, you know, find this boring. But for those of us who are not so keen on the maths side of it, to work things out, when you've got a book as good as this, goes into the formulas and it's very well explained, and I've been going through the examples here, and basically this table here is giving the volts and the amps, and by doing the calculations with those we can work out the watts, and we can work out the resistors, and they all tally up with what's said at the bottom with a resistor of 12 ohms, and that's shown here in the calculations. Now remember what we said about this circuit. Remember I've still got a bad shoulder. See what we've got here with this circuit here. These are very, very obsolete transistors, OC44s, and we've been playing around with them, and we've just been bunging in one germanium transistor after another until we found one that's worked, which is hit and miss. We know the circuit works because I've made this before, as I've said, and used it. And excuse me, you're going to have to cough. So my plan is, what I want to do is basically apply the maths, what we worked out here, to work out the resistance here for completely different transistors. Now, my plan is, now I don't know if it's going to work, but this is new to me, I'm sharing this with you. I've never ever done this before in my entire life, ever. And certainly never filmed it before. My maths is terrible. So, if I can do it, and my maths is terrible, so can most of you who are struggling with this, trying to work out the basics of working out your resistors. So like I say, what I want to do is change the circuit the other way around. Now, as we all know, that PNP transistors, if you look on this schematic, is all connected up to the positive. You've got the resistors and everything onto the positive. Now, no one's told me this. This is how I think. I could be completely wrong. So the only way to find out is to try it. So what I plan to do is to move the circuit round. So basically, we're going to change the circuit round and have the resistors, instead of going from the positive side, they'll be going from the negative side. Theoretically, this should work no problem. But when we've decided on what transistors we're going to use, how do we work out the resistance values? Because the difference between silicon transistors and germanium transistors is quite a bit. Germanium transistor uses more than what a silicon transistor uses. So we need different resistors to do what we want. And what we want is an oscillator circuit this size that will run on 1.5 volts. That's the plan. Hello YouTubers, hello. I've got quite a nice collection of parts. Been doing very well. I've got a few more to get off. 2 seconds. This is about as far as I got. I've been doing bits and pieces on and off. Do a bit, go away and do something else, read, watch YouTube videos, come back, do a bit more. But I'm not very happy. I'm not very happy because my 25 watt soldering iron decided to pack up. This is what's left of it. 25 watt. It's an ATEC soldering iron. I like these. I like these a lot, as you know, because I've got 3 of them. But I haven't used the 25 watt one in a while, and decided that it would be better iron, better recovery rate, continuously soldering off these parts. Now the other day, well actually more like quite a few days ago, I was using my soldering iron, and it seemed to didn't want to work then, and then it started working. I thought it was the socket that it was plugged into. It isn't. So do you guys want to know what's inside? Here's the element. Obviously I've tested it with the multimeter across the plug. Where's the plug? As you can tell, I'm not very well organised. I chucked it on the floor. So anyway, I tested across the plug, no resistance. Compared it with another soldering iron in case I made a mistake. Got resistance, which proved my point. So I decided I would rip out the element, and I wanted to have a look to see what was inside. So I snapped the wires off the top. That's what's left of one of them. I don't know if you can see that. And then on there, and then here's the element. This is the actual bit that gets hot inside your soldering iron. and if you noticed, it snapped off right in the middle. So I guess that's why it's not working. It's in this, you've got two of these insulators on there, which I'm going to keep. They might come in handy. Actually, it goes the other way. I think you'll find that's supposed to be in one piece. It's difficult with one hand. As you can see, that goes on there like that. And if you look at the joins, the two pieces of, as you can see, they do join up. So that would be one long piece of, I presume that's ceramic. So we got a new soldering iron on order, which is the last thing I wanted to buy. And you can see it snapped there as well. That's where it's gone. Well, these things heat up, cool down, heat up, cool down. They don't last forever. Sooner or later, something's got to give. And I suppose carrying that big big solder bit on there might not have helped. I don't know. I don't use this guy very often, but decided to use it for these because, again, constantly unsoldering all the time, you know. So how did I know about this? Well, I went on to the Amazon to order the iron, and I wondered, well, do they sell spare elements? Yes, they do. They do sell spare elements. So that must mean you must be able to get the element out. So shoving, pushing, and whatever, found out that it does come out. It just slots in the end, and you push it out from the other end, probably from the flex, which by this time I'd cut off. This is not going to be easy with one hand. Hang on a sec. Hello YouTubers. There's another day gone by. I'm taking the parts off the power supply board. I'm doing quite well. But after the parcels arrived today, I'm kind of thinking that I might be wasting my time, as you'll find out. You know how I said that I'm skint because I bought 2 Cygnett generators? Well, I'm even more skint now than ever because I've gone and bought something else. So I'll show you what the other things are that I bought. And it was a cinch, really. It was something that I could not resist on eBay. I thought, you know, it's a golden opportunity. These opportunities don't come up very often. And I grabbed it with both hands and I won. I won the bid. So what we're talking about? Have I got a surprise? I tell you, I've got enough parts now to start a factory. Honest. I'll show you. I'll just get the first box out. Yeah, the first box. This is the contents of box number 1. Here we have got half watt and quarter watt resistors, and we've got them in their thousands. Not bad for what I paid. I'm not going to tell you what I paid. 1.8k. I mean, look at that lot. Have a look to see what the value on these are. So what I'll be doing is going through my stock of resistors, seeing what ones that I do have, going through these and making up a small packet of what I don't have, and sticking them all in my stock, as it were. And I'll keep these wrapped up, you know, as and when I need them. But I've got enough resistors here to make all sorts of things. In fact, I think, and you guys have already probably worked it out, I'm never ever going to get through these. I'm never going to use all these resistors. It would be nice if I did. Very, very nice. Right, this is box 1. So let's get box 2 out. It's even more interesting than this. I wasn't going to get them all out and show you everything individually and bore you all to death. But there's a cross section of what we've got in here. And I mean, there is everything. Pots, electrolytics, transistors, resistors. There are some things in here I've never seen. And there's nothing to say what they are. I mean, this one, for example. These got Mexico written on them. And a number. It's a coil of some kind. C8626. Thick multi-stranded wire in a coil. Feels like it's on some kind of ferrite or some kind of... There's no instructions, no idea what they are. And there's another one here that interested me here. I don't know if these are crystals. 4 pin. 4 pins coming out, 2 on either side. I have no idea what these are. Right, we've got 40.960, and then it's got 12/90. That might be a date code. There's a whole bag of them. All kinds of stuff. Absolutely loads. There's even surface mounted diodes, but there's nothing on them to say what the diodes are. So, and for surface mount, they're quite big diodes. So what they are, I have no idea. So, I'm going to get back to what I was doing. This is going to be a bits and pieces video. I'm going to edit this up now. Yes, look at these, look at these lovely switches. These are toggle switches. Toggle switches. I tell you, there's a lot of stuff in this bag, and some of it is very useful. I mean, look at these. 400 volt, 0.6J, sorry, 0.68J. So I would say that's what would that be? 68 picofarads, maybe. I'm not too clever on those numbers yet, but anyway. And then there's a third item. These are all half-watt resistors. It's a whole bag full of RS components, all half-watts, the whole bag. All different values. These are in smaller quantities than what the first lot I showed you, the other lot. These are in the individual packets, and they're all numbered and all marked. So yeah, I've been busy. I bought stuff that I wouldn't normally have bought. I couldn't resist this lot. It'll come in one way or another. Alright, I know the electrolytics might be old. I'll test them before we use them. We'll have a use for all of this, but like I say, there's enough parts here that I'll never ever be able to use them all. It'll be nice if it did.